Hi, good morning everyone. My name is Sarah Jane Gan. We were going to present our group experiment results. Before we tackle our reports, let me introduce my group mates. Priya Grace B. Menes, Shanine Martinez, Princess May F. Benega, Remy De Jesus, and Bria May For You.
The water used for the sample was at first clear. However, after adding Benedict solution and swirling to when combined, it became blue. But if you warm it for 3 minutes, the color will shift, becomes a clear aqua blue. Glucose from the sample it was evident at first, yet once adding the Benedict solutions and after mixing, color resulted. Blue, although if you warm it, it will have a new hue in 3 minutes in an olive green. The starch was initially clear, yet after adding Benedict solution and mixing it to combine, the solution became color blue. Although if you warm it for 3 minutes, its color will change to a clear aqua blue. Using the sample's orange juice, at first it was clear, but after the Benedict solutions including and color emerged after combining, green. However, if you reheat it in 3 minutes, it will have a different color, a cloudless yellow. The instance, a typical soda, was clear at first, but after including Benedict solutions also mixing for combine, it became green. Although if you warm it for 3 minutes, the hue will alter a bright orange-brown, because Benedict solutions turns orange-brown in the presence of simple sugars. The test diet soda was originally clear, but after include Benedict solutions and mixing to combine, it became green. Although if you warm it for 3 minutes, nothing is altered, because diet soda has no amount of sugar. The oil had a knowable starting color. Then when Benedict solutions was inserted and combined, the hue of the instance reduced became less yellow. If it was heated for 3 minutes, the color did not change, comparable to a diet soda.
After we shake the starch and add a water sample, the first shade was colorless, but after adding 9 drops of Lugol's and radiant stir to combine, the shade turned dark blue or black. The example glucose was initially colorless after shaking the starch before use, but after adding 9 droplets of Lugol's reagent and mixing, the color changed dark blue or black. The tone of an example starch initially after a colorless during the starch prior, but following 9 more amounts of Lugol's, both reagents the mixing changing color black or dark blue. Initial shade of a combination was beige, after jolting a starch ahead of use as well as an example's orange juice, but following 9 more amounts of Lugol's, both reagents to unwhirl the color mixtures modified to dark blue and black, but following nearly 2 seconds of the mixing dark blue and black in color removed, and the mixture retreated to beige.
The color of the simple regular soda was initially brown after shaking the starch before use, but after adding 9 drops of Lugos reagent and mixing, the color turned dark or black. After shaking the starch before we use and add the simple diet soda, the initial color was brown, but after adding 9 drops of Logos reagent and swirl to mix, the color become dark blue or black. After shaking the starch before we use and add a simple anno or oil, the initial color was colorless, but after adding 9 drops of Logos reagent and swirl to mix, the color become dark blue or black.
The paper becomes translucent when soaked with water, but this effect goes away as the water evaporates. After the brown paper being soaked in the water, the brown paper shows that there are no lipids in that sample. The brown paper turns translucent and light comes through after being dried for 10 minutes. It means that the brown paper shows that there are lipids in the sample. The presence of the oil on the paper causes light not to scatter so much, making the paper look somewhat translucent. After testing for lipids for the sample cream, the brown paper turns translucent after being dried for 10 minutes. It is the same as the sample oil because cream are also a blend of oil, so the brown paper shows that there are lipids in the sample. After testing for lipids for the sample orange juice, the brown paper shows that there are no lipids in the sample of orange juice after being dried for 10 minutes. The paper becomes translucent, but this effect goes away as the water evaporates.
The sample water initially has no color, but after being mixed with the burette, it turns aqua blue or light blue. It signifies that the presence of proteins is indicated if the test sample changes from being colorless to blue. The initial color became colorless after the addition of a modest amount of test starch. The color changed to a clear emerald after the burette was placed. The initial color became colorless after adding the 1 ml sample of egg albumin. However, when the burette is added and mixed, the color turns to dark blue. Egg albumin plus burette solution is a positive control for the protein test. The initial color was rendered colorless by adding a sample of glucose. However, when the burette is added and mixed, the hue turns green. The initial hue changes to brown when ordinary soda is added in small amounts. Burette droplets were used to modify the color to emerald green. The sample oil initially has a yellow tint, but when a burette is added, it turns blue.